Pressure is defined as the force per unit area that one material exerts on another. For example, consider a 10-pound cube resting on a table. If the area of each face of the cube is 4 square inches, then 10 pounds is distributed over an area of 4 square inches. So the cube exerts a pressure on the table of 2.5 pounds per square inch, or 2.5 psi. In SI units, pressure is measured in newtons per square meter, which is called a Pascal. For a liquid, pressure is exerted on the sidewalls of the container as well as on the bottom. Pressure sensors usually consist of two parts. The first converts pressure to a force or displacement, and the second converts the force or displacement into an electrical signal. Pressure measurements are made only for gases and liquids. The simplest pressure measurement yields a gauge pressure, which is the difference between the measured pressure and ambient pressure. At sea level, ambient pressure is equal to atmospheric pressure and is assumed to be 14.7 psi or 101 kilopascals or kPa. A slightly more complicated sensor can measure differential pressure, the difference in pressure between two places where neither pressure is necessarily atmospheric. A third type of pressure sensor measures absolute pressure, which is a measure with a differential pressure sensor where one side is referenced at 0 psi, which is close to total vacuum. A Bourdon tube is a short bent tube closed at one end, and when the tube is pressurized, it extends to straighten out. This motion is proportional to the applied pressure. Notice that the displacement can be either linear or angular. A position sensor, such as a POT or LVDT, can convert the displacement into an electrical signal. Bourdon tube sensors are available in pressure ranges from 30 to 100,000 psi. Typical uses include steam and water pressure gauges. A bellows pressure sensor. This sensor uses a small metal bellows to convert pressure into a linear motion. Look at figure A. As the pressure inside increases, the bellows expands against the resistance of a spring. The spring is often in the bellows itself or is the bellows. This motion is detected with a position sensor such as a POT. Figure B illustrates a differential pressure sensor, which can be made by enclosing the bellows in a canister. Here, the pressure from outside the bellows, pressure 2, tends to make the bellows compress, whereas the pressure 1 tends to make the bellows expand. The position sensor of the shaft is a function of the difference in pressures inside and outside the bellows. Bellows are capable of more sensitivity than the Bourdon tube in the low pressure range of 0 to 30 psi. Some commercially available pressure sensors use the piezoresistive property of silicon. The piezoresistive element converts pressure directly into resistance, and resistance can be converted into voltage. These sensors have the advantage of no moving parts and are available in pressure ranges from 0 to 1.5 psi to 0 to 5,000 psi. They are typically used with fluids or gases, have an internal amplifier, and outputs a voltage that is directly proportional to either gauge or absolute pressure.